Here we're dividing one fraction by another fraction. Now usually it's easier if instead we multiply by the reciprocal. So I'm going to change this division sign to multiplication and then also flip the second fraction around. We also need to remember a couple of properties of exponents. If I have bases multiplying each other, then that means I add the exponents. And if I have division, then that means I subtract the exponents. So the exponent of the numerator minus the exponent of the denominator. So first I would start by grouping these and simplifying each variable. So that 9/10 doesn't reduce, so we'll just copy that. But here we have p to the 1/4 divided by p to the 3/4, so we would just subtract. So I'm going to rewrite that as -2/4. And then simplify our q's. Let's get all of those together. So we have q to the 5/2 and subtract the 9/2. So that would give us -4/2. And then remember that we're going to flip that second fraction, so times p to the 5/4. And then on the bottom of that fraction, 6q to the 7/2. Now we're still going to get our like terms together. So we basically can reduce these numbers here. I'm going to just say that 3 goes into 9 3 times and 3 goes into 6 2 times. So that's going to simplify to 3/20. Remember, you can just stick that in your calculator and reduce that fraction. And then also we have p to the -2/4 times p to the 5/4. So we're going to add those fractions. That's going to give us 3/4. And then also we need to simplify the q's. Here in the numerator I have q to the -4/2, and in the denominator I have q to the 7/2. So that would give us, oops, I made a p. That would give us q to the -11/2. And then let's simplify that further. So 3/20 does not reduce. We have p to the 3/4 in the numerator. And then anytime we have a base with a negative exponent, just remember that we can rewrite it by flipping that into a fraction and making the exponent positive. So that means our q can go in the denominator, and that exponent is now going to turn into a +11/2. So that means our answer is A.